So, who am I? My name is Jan. I am a DevOps team lead at NIL, which is part of Conscia Group. I have Linux expertise and I am focused on the domain of automation. Also, I am on a certification path toward Red Hat Certified Architect. And for my formal education, I have a master's degree in electrical engineering. A little bit about NIL. We are based in Ljubljana, Slovenia, and we are globally recognized system integrator. We have quite a lot of customers that are large to medium-sized companies, and we have been around for a couple of decades. A little bit about Conscia. It was founded in 2003. Today we have 1,700 plus employees, and we are serving some of the largest organizations within the financial, healthcare, and public sectors across Europe. So, thank you all for attending. Welcome to this webinar. Today, we will explore why automation matters, how we can help you implement it, and share some real-life use cases we have developed successfully for our clients. And throughout this session, I will focus on three key examples that will be autonomous patching, hypervisor observability, and automated reporting. So I hope these use cases will give you some insight into what can be developed for you. So let's dive into it. Why does automation matter? First, manual processes feel manageable until they aren't. Patching cycles extend into one another. Audits become long and painful, and configuration and errors creep across teams. Without automation, you only rely on heroic effort rather than having a reliable system. When we looked at the bigger picture, we saw a pattern. Many tasks were manual and highly repetitive, like system patching, user onboarding, new systems deployment, and so on. All of these tasks were highly repetitive. They were often done, at least in our case, in a copy-paste fashion. That reminded me, if you know, the song Technologic from Daft Punk, where the robot just sings the same lines over and over again. It reminded me of that. But here's the catch. We, as humans, are not robots. We become bored and our focus drops if we are clicking the same thing over and over again. And that's why, because our focus drops, human errors can creep in, which can cause a lot of havoc down the line, like security vulnerabilities, compliance gaps, and of course, operational risks and higher costs, because we have to do unneeded troubleshooting and a lot of that stuff. So that's why automation matters. The challenge is not just about saving time, it's about eliminating human errors and creating a foundation that we can create a reliable and scalable IT operations upon. So how did we address this? First, we needed a single place to run our automation. Scripts, playbooks, workflows. When we asked engineers with our clients and inside NIL, we found dozens of disconnected environments. Each team had their own environment, had their own tools, had their own stuff they did, and their own setup. So we decided to build a unified platform which serves as an entry point for anyone that wants to come into the world of automation. We have pre-prepared tools that allow users to start working with them without the need to set up their own infrastructure, so that we do not need many disconnected environments and demo labs. Next, we had to tackle standardization. As I said, a lot of teams were using different tools and practices. This created a lot of inconsistency. So we defined clear rules, how the platform is used, who can access and what they can access, and also what resources are available inside the platform. Then we tackled consolidation. Knowledge and scripts, they were scattered everywhere. Locally on computers, some Git, some other like SharePoint documents, and so on. We centralized this in Git. For our use case, we are using Azure DevOps. And also, we have adopted continuous integration and continuous deployment principles so that we have automation that is versioned, reviewed, and repeatable. So finally, we asked ourselves, how can we get real value from this platform? This is where we wanted to have enhanced services. It is not only that we build automation, we want to build automation that helps you, our customers. So the solution is not just about technology, it's about creating a scalable, secure, and also efficient automation ecosystem. Let's say a platform that we can build on. So what is this platform I'm talking about? We have developed this platform so that it can serve as a foundation for all automation initiatives. It integrates tools like Red Hat Ansible Automation Platform, that is the core of the platform, and serves as a central management for Ansible playbooks. The next tool we have is Red Hat Satellite. It is a tool to manage packets and updates for Linux systems. And also it works with Red Hat Ansible Automation so that it can provide collections for Ansible. Next, as I said, we wanted to consolidate everything. So we use Azure DevOps as a Git tool so that we have a development and version control playbooks and scripts. Next, we have HashiCorp Vault. This tool is used so that we have central credential management. And next, of course, we wanted not to have only these 4 tools, but many other tools that are already used by you, the client. So I have mentioned the Linux environment. We can also incorporate a Windows Server update services that we can control then the updates for Windows environments. So the design of this platform is modular and flexible so that we can integrate tools that are already used by you. So how do all of these tools come together? It all starts with Git, where we keep all of the playbooks and scripts. And this repository where we keep the scripts and playbooks is available to the automation controller. This automation controller can execute the automation, but we did not want it to be a security vulnerability because we do not want a single point of failure. That's why the automation controller can access endpoints in any environment that we want via Linux jump server. It does not have direct connection. So what can we manage with this platform? We can manage either operating systems or infrastructure. As long as it can communicate via SSH or WinRM or API, we can include it. Also, the platform is designed to be modular and flexible. That's why there is this extra red square. We can add any tool inside of it that you're already using to expand this platform or framework. So now that we understand the foundation for automation and the building blocks that we have designed for this platform and how they fit together, let us explore the comparison between managed and do-it-yourself automation. A lot of clients over these past couple of years that I have been working with automation ask themselves how to even start with this. How do we implement automation? And they face challenges like they don't have expertise, they don't have infrastructure, and that's even before we can start designing or implementing or developing the first playbooks. So that's why managing automation often means that we have disconnected environments and tools and also inconsistent practices. Usually people just like experiment what works, what does not work. Yes, disconnected, inconsistent. Okay. The next thing is security often becomes an afterthought. Why? Automation usually needs to just work as soon as possible. The engineers developing it do not concern themselves with security first. They usually say like, we will get back to it, but that never happens usually. So, and also the limited think capacity of some teams and clients that we have is usually also impossible to scale this platform and the tools that are disconnected. And also because of that, there is maintenance overhead that they just cannot handle. It becomes unmanageable. So we decided to make it simple. We created a managed automation platform so that you as our client can skip the complexity and start with a predefined platform that is standardized and ready to use. Security is also the core of our platform, and we are using centralized credential and identity management. If you have like Active Directory, or if you're using Azure Enter ID, which most companies today use, we can integrate it so that we can ensure the right people have the right access by using granular permissions with role-based access. And also, there are other benefits to this. Our platform grows with you, scaling at your own pace as your needs evolve. It comes with built-in integrations with the tools that you already have in place. And most importantly, this is something extra, this platform is backed by engineers that have expertise that can guide you through every step of the way, from design to implementation, so that you can focus on results, not complexity. So to sum up this do-it-yourself versus managed automation, the bottom line is you can focus on your business because we can take care of your automation needs. Okay. Since we have now covered the theory, we will be going to the real-world applications. But first, I will check the questions if there are any. Okay, I can see that. Oh, Giga had a question about Netbox as a source. Yes, that is something that we can implement it. As I said, we can use any tool or application that we have, as long as it uses like SSH, WinRM, or API calls, we can implement it. If you have Netbox as a source of truth, we can implement it so that automation platform can use it as a source for inventory, if that is what you were saying. I hope that answers the question. Okay, good. Thank you, Giga, for the question. You can just write it in the chat. I will stop between sections and try to answer them. And if you can't answer it, I will have a discussion later. Okay, so the real world applications, we have covered the theory. Let's look at the use cases. So in our production environment, we have several automations that we have running successfully. I will focus today on 3 examples. The first one is autonomous patching. The second one is hypervisor observability. And the third one is automatic reporting. I have chosen these examples because I want to show the flexibility and the extendability of the platform. And I think these 3 examples can show you that, so that you have some idea of what is possible. Okay, the first use case, which is managed autonomous patching. What we will cover, why patching even matters, why do we need this? The automation requirements, what we need to implement the solution, and the technical solution that we have developed. Okay, why does patching even matter? As you can see, exploits. Almost 40% of attack vectors are comprised of exploits. Most of these exploits are known vulnerabilities that we can remove by having regular patching intervals. And how can we guarantee that these patches are regular? Well, with automation. That's why we're here. So what are the requirements for this? We need deep knowledge of the environment that we want to introduce the automation into. And of course, the understanding of interdependencies in the environment, like which service comprises of which components, which service or application communicate with each other, and so on. If we can meet these 2 requirements, we have victory. So what are the objectives for this use case? The first one, we need it to be scheduled in regular intervals. The second one is we want engineers or department heads to be notified that this process has completed. And the third one is we want this process to have automatic health checks, so that when changes happen, it can automatically check if the health of the applications is okay. Then the fourth one is we want the system to be autonomous. We do not want engineers to be involved directly in the process. So if we achieve that, we are on the right path. Okay, let's go through the automation, the automation steps real quick. The first is that We have first a schedule. This schedule is defined on the needs of the client. It is based on the agreement between teams responsible for the environment. And from this point on, when the automation is processing playbook, we have two outcomes. The first one, which is the green light, and it's the top one, is successful. And the second one, which is unsuccessful or failed, is the bottom one, so that we know which outcome we're talking about. Okay, the first thing we do is that we prepare updates, security vulnerabilities, patches, and so on. For this, we can use either Red Hat Satellite for Linux environments or Windows Service Update Server for the Windows environments. Next, we start preparing the environment for changes. So we stop the applications and we create snapshot on the, in our case, vCenter, but we can use any other hypervisor like Hyper-V or anything that you use. Then we can start applying changes. So we apply patches and we start rebooting the systems. So once the systems are back up, we start the applications. But this is where the benefit of this process comes in. The application health checks are not just like ping or telnet that, I don't know, SQL database is up. We also want to check if the front end actually returns the site, that database actually is processing data, and of course, if backend is actually providing some changes to the front side. So the first health check is that we want to do is that we try to log in to the actual application. We want to check the database if there are actually changes in the database, and so on. These health checks are very important here so that we can make this process autonomous. And after that, we want to notify engineers or department heads that the process has completed. If it was successful on, I don't know, all nodes, or if it failed on some nodes. Usually it's some nodes, it's not all nodes, because there are some, as I said, configuration errors or bugs or something like that. And of course, if the process was unsuccessful, we also create a ServiceNow ticket so that some engineer can be assigned to it and start troubleshooting. And in the last step, of course, because we sometimes forget this, the automation automatically deletes the snapshots for this process after 1 week, so that we have some time if we have created some changes and they are not running okay, so that you can revert the system and try again. Okay, so what are the results and benefits of this use case? The first one is that we have successfully created the attack surface smaller, because we have regular intervals where we're patching. We have removed a high percentage of attack vectors. At the same time, we have freed up some resources because teams no longer need to spend time keeping the systems up to date. It happens autonomously. Of course, we have regular intervals, yes, and I want to showcase you the actual results we had with the client. This is only the time parameter. We are not including here the fact that engineers don't actively have to participate in this, except for the production environment, but I will get to that. The development and staging environment in October 24 took us 2 hours and 40 minutes and 4 hours. And now it takes us about an hour to complete the patching. That is 75% time improvement and 60% time improvement. Why 1 hour cap? Because the system still needs to apply patches, reboot, and so on. That takes most of the time. Okay, and for the production environment, why it takes 3 times more? Because it is not fully autonomous. That is what client requested. We need approval from the application team to actually reboot the servers, and then application health checks happen autonomously onwards. That's why it takes 3 times more. But still, it is a 50% time improvement just because we have the first part of the process automated. I want to say here that you don't have to build this yourself. We offer this autonomous patching as a managed service delivered through this managed automation platform. You get full standardized and secure solution without the need to actually set it up yourself and maintain it. Okay, these are the results for the first use case. Any questions on this? Okay, I guess no questions. So let's go on to the second use case, which is managed hypervisor observability. We will look at why observability matters and the technical solution we have developed. So why does observability matter? With some of our clients, we have faced the challenge because multiple departments use the same equipment. So the resource usage is quite high. And we did not have any insight what the resource usage was. Was it production? Was it only demo and labs? Was it, I don't know, some archive VMs that are long forgotten? Something like that. So we wanted to know how many resources does each department use, like virtual CPUs, how much RAM, how much hard drive space. And of course, also very important, the VM count. How many VMs are running per department, how many VMs are off, and when actually was this VM last accessed or used. So for the automation objectives, we have, of course, it needs to be scheduled. We wanted to gather data from an infrastructure component like Hyper-V or vCenter again. And we wanted to publish this data to either SharePoint or some other document library you're using. And we wanted to actually notify the engineers about their use on the equipment, because maybe some engineers just need like a reminder of the long forgotten VMs. And that's how, if we achieve this, we have some side of victory. So the architecture for this is this. We are introducing new components to the platform that we are already using. This is the red square that I have mentioned before. We are integrating a Microsoft Graph API and SharePoint. And of course, we are integrating vCenter or any other hypervisor that we can use or you're using. So yeah, in this case, I want to show you that the platform is extendable, and of course it is flexible with any tools that you're using. If it's not SharePoint, it's maybe some other document library. Okay, so what are the automation steps? The first thing is that, of course, we need schedule. This schedule is based on the client needs. It is either on weekly or it is on monthly schedule, depending on how many changes you have in your equipment. The second step is that we set up the actual environment so that Python scripts can run without a problem. Then we gather data from the hypervisor. In this case, it is vCenter, or maybe we can use something else. And then we start to executing the Python script. So the Python script takes the data that we gathered and reformats it into a report that you want, like graphs and tables. And then we upload this report to SharePoint and of course send notification to the engineers and department heads so that they know what resources they're using, how many virtual CPUs, how much RAM, how much hard drive space. And of course, we want to also point out which VMs have not been used in a while and are just sitting there so that they can be deleted. So what are the results of this use case? First, we transform this resource monitoring from a manual and time-consuming task into a fully automated process. So this solution can run either daily, weekly, monthly, based on your needs. Then we don't have to chase people around anymore because they're directly notified. The notifications are sent via Teams or mail or whatever else, and they know that what resources they're using. And of course, this saves some time and also reduces frustration and ensures that resources are managed efficiently. And I want to point out, because we have implemented this for a client, in the first month when we have implemented this, 10% of all VMs on that infrastructure were straight up deleted because they were long forgotten demo labs or some other testing resources or whatever. But 10% in the first month, I think that is great success. Okay. This was the second use case. I will check questions now. Frederick sent something. Oh, great question, Frederick. So he asked how we are using the notifications. It is either using the generic Teams channels or all notifications, or if you're using different channels for different systems applications. This is totally up to the client. We can send notifications via emails. We can send it in like a chat, or we can send it directly to engineers. And it is not like we only use one channel. We can use different channels. We can use different like methods of notification. It is not just limited to Teams. I have included this here because it is something that we are using via Graph API. I hope that answers a part of this, I guess. Okay. Okay, I hope I answered this correctly. Thank you, Frederick. Great question. Okay, managed automated reporting. So why does reporting matter, and what technical solution we have developed? So why does reporting matters? As you can see on the picture, if you know the Office series, Michael has sometimes sentences like this. While we're creating a report from unstructured data, we usually face that we don't know what actually we want to create from it in like a human readable form. It's hard. We need to put structure to it and then make it into something that is human readable and recognizable for others. Of course, the report creation is a time-consuming and manual task. So how did we tackle this? Not only that we have used automation for this, but we have also included an AI model inside this, so that the automation creates this structured data from unstructured data, so that graphs and tables and other metrics that we need. And then we have included the AI model that takes that structured data so that it has some context and it can create some extra insights for us and creates a human readable part of the report. So that someone can take this report and is like, okay, I'm looking at these graphs, I don't know what this really means, but the AI can create a report, okay, in the last month, there were, I don't know, like CPU usage on this switch was very high from like this and this time. Or maybe like you have high RAM usages in this and these times. This is the actual enrichment that I'm talking about. And also I want to point out that at this point, if you can do it by hand, you can do it with automation. And even better, if you can do it with automation, you can enrich the results with AI. In the past year, 2 years, there has been a lot of talk about how AI can replace some things or make things better and so on. But AI still needs some structured content and context to create actual enriched reports or actual enriched content with extra insights. If you're using unstructured data, the report also will be unstructured. Okay, so automation and AI go hand in hand. That is what I want to say here. And also, for security part of this, we at Conscia and Nil have AI hardware that we can process these LLMs. And I want to say here that your data does not leave the data center premises. If you have AI hardware that can process this, we can implement this in your data center, so that we also are thinking about the secure part of this. Okay, so objectives for this. Of course, we want this process to be scheduled. The second one is, in our use case, we wanted to gather data from Zabbix. We can also use the other tools here, like maybe if you're using, I don't know, Grafana, Loki, whatever, some other tool that we can communicate with. The third thing is that we wanted to create a report and update it to SharePoint, of course, that it is available to others. And of course, we wanted to enrich the report using an AI. So this is what we want to satisfy to create victory. Okay, the automation steps. As you can see, this diagram is almost identical to the previous one. We have a schedule that is based on the agreement with client. Next, we prepare the environment so that the Python can run as it should be. Then we gather data this time from Zabbix, not from vCenter. So this is another like infrastructure component. Then we execute the Python script, which creates the report from Zabbix unstructured data and has like structured data. And then we can leverage an actual LLM model that can create human readable content and enriches the report. After that, we upload the reports to SharePoint. And of course, we want to notify either engineers, department heads, or other stakeholders with the report is ready. This can be anything. In our case, it is Zabbix data, but it can be anything that you desire. So once again, as I want to point out, this shows the flexibility of the platform. We can add components either directly with the automation platform or by using Python scripts. Okay, what are the results of this use case? So we have now an automated process that creates a report and enriches them with AI, turning raw data, unstructured data, into a human readable content so that there is it is not just graphs and tables, it is actual text that you can read so you can have an idea what is happening. And of course, as a bonus, deadlines are no longer a concern because reports are generated automatically on a regular basis. And of course, I want to point this out again, security remains top priority. Data does not go out, I don't know, to the Azure Foundry or ChatGPT or other premises that data can leak out of. It stays in either your data center if you have the hardware or in NIL data center. And of course, this is just an example of a report. We can include any other tool that you want to gather data from to create any other insights. In our case, it was Zabbix. So yeah, I hope this gives you some insights. Any questions for this use case? Okay, I guess no questions. We will also have a Q&A session at the end, so don't worry if you have anything further to ask. Okay, now that we have seen the impact of automation in real-world scenarios, I want to show you how we create a VLAN on some Cisco switches and a Cisco UTS on demand using our platform. It is not only that the automation can be scheduled, it can be also on demand, so that we can remove human errors in some particular use cases like one-time things, let's say system onboarding or VLAN creation that is based on daily needs. Okay, so Ansible playbook steps. The first step is that it needs to be triggered on demand. We can input what VLAN we need and the playbook takes care of it. So I want to show you the, let's say, playbook template that what looks like inside the automation platform. I have blurred some content because it is based on a client, but still, it is network automation add VLANs playbook. We can execute it by clicking the rocket logo. It always makes me laugh when I see this. I guess they implemented it that way. Okay, so the first step is that this is an actual playbook and what the user can see when the playbook is running. I want to show you the interface of the Ansible automation platform, what it shows you. So the first step is that we want to check the OS version of the device that we're using. So we first set the facts and then we show which platform we have. For the first host, we have CAT, and it is a Cisco Catalyst switch. For the second one, it is PDC switch, and it is running Cisco NXOS. That means it's a Nexus switch. And then we have the UTS device, which is running Cisco UTS OS. So first, we want to configure the VLAN on the Catalyst. Then we want to configure the VLAN on the Nexus switch. And then we want to configure the VLAN on the UTS manager. What I want to show you with this use case is that we can also configure the components for infrastructure. I showed you before in the other use cases, we can gather data from them, we can configure them, and so on. So yeah, this approach is something that we really wanted because it ensures consistency across multiple platforms. Because sometimes I have seen this with my own eyes, and I did this. You have like 10 or 20 switches, and you can forget to create a VLAN on some of them. And then you're wondering, why does this VM not have connectivity? Of course, it does not have it because it is a misconfiguration. It's an error. So you need to troubleshoot, you're wasting time and so on. And we want to have consistency, and we want to reduce the human error and the risk of it. So I hope you have some insight into how the automation actually looks like in the Ansible automation platform. And I want to take a step back now. I have shown you 3 use cases, autonomous patching, the hypervisor observability, and how we can use almost the same workflow and add new components to it. And also this demo of a use case that we're using so that we have a repeatable success for this environment. Okay, any questions for this use case before we continue to the key takeaway? Okay, Giga has a question. So after successful patching, how does autonomy check the services working, I guess, that are running on the patch devices? Is that standard? Okay, as I mentioned before, the 2 requirements for the autonomous patching are that we need deep knowledge about that environment and how the services are connected. The deep knowledge also includes how the services are running. Based on that, and of course, the fact that we need to work with other teams, the application team, database team, and other teams that are taking care of the environment, we need to create health checks specifically for those services. Like if you have a Zabbix service that is running on a, let's say, Docker container. It has 3 containers. The first one is front end, the second one is database, and the third one is backend. For the front end, we don't want just the health checks to be like ping. We want it to actually try to load the page. We want to see if the page is actually up. If we only ping it, we usually get either it's pinging or it's not. It does not tell us a lot. So yeah, we want to load the page. That is the first thing for the front end. Then the second one for the database. We don't just want it to be like, okay, the SQL port is up. It does not tell us a lot about the database, only that it is ready to like communicate with it. We also want to actually log into the database and check if the data can be written or it is actually being written by other processes. That actually ensures that the database is running correctly in like 90%, 99% of use cases. And then the third thing is that for the backend, we actually want to log into this Zabbix front end. We want to log in with a user or SharePoint to actually see if it is giving us content, if there is some changes being made and stuff like that. So it's not actually standard, it's tailored to the actual, let's say, process or service. I have done some philosophy here, but I actually, does that answer what you have asked? Okay, great. Thank you for the question. Any other questions? Okay, great. Okay, key takeaways. What I want you to take with you from today's webinar is that automation is your ally. It's not always simple because building an automation ecosystems requires more than just like scripts, workflows, and like some imagination on how you can automate this. It also demands a secure and scalable platform so that you can have a standardized process actually, and it incorporates careful planning to actually implement this platform based on your needs. And of course, we have been talking about this do-it-yourself versus managed approach. And I fully support this, that organizations start with do-it-yourself approach, so they can have some insight into actually what they need, what it is that they want. And from then on, they quickly probably face challenges like I have been talking about. There are disconnected tools, there are inconsistent practices because you're actually experimenting. You are trying things out, you just need it to work and so on. It can actually create some unfortunate security gaps with this. So yeah, that's why managed automation platform, in this case, makes sense. With our platform, you get a ready-to-use foundation, which includes I have been talking about this, the enterprise security. We have baked in the central credential and identity management. If you don't have like identity management, we can implement it for you, or any other like tool. And of course, we wanted this platform to be scalable and flexible. That's why we have developed a lot of these integrations with maybe the tools you use or are already using, like Azure Enter ID. Someone mentioned Netbox, of course, the SharePoint. Most organizations today use SharePoint, and we can communicate with it via Microsoft Graph API and so on. So yeah, we don't want extra complexity. We want to use the systems that you're already using so that you can create some extra value for you. So yeah. And for the last thing, we can handle everything you didn't think of at first, like the platform setup, governance, scalability, and of course, the very important thing, the ongoing optimization. Automation isn't just like you put it up and you forget about it. There are changes in the APIs. There are new versions of things like Ansible and other stuff. So yeah, ongoing optimization, very important. And of course, we can help you. You can focus on your business and we can take care of your automation for you. Okay, so how can we actually help you? First, we can provide you with a consulting and professional services to guide you from actual strategy to the actual implementation and realization of your specific use cases so that you can have no more like repetitive tasks, and we can bring some extra value into your environment with your existing components. And the second one is that we can deliver a fully managed automation platform that takes care of almost all automation initiatives. And we guide you through design and deployment to actual ongoing operations and help you with that. So with Neil's managed automation platform, we can realize any use case tailored specifically to you. It is either small or big, does not matter. We can realize it. So yeah, that's a pitch from me. And of course, we have now reached the questions and answer sections. So please, if you have any additional questions, if you want to dive further into something, it is now the time for this. Theodore had a question. Do you have any other interesting use cases you can share? Sure. There are a lot, but another use case that comes right into mind is like bandwidth monitoring. Some clients of ours have a need to actually check if the internet service provider is actually providing them with the speed that they actually have via, I think it's MPLS, between an HQ site and a remote site. So we can use this platform to create these automated reports and, of course, automated bandwidth measurements between the HQ and the remote branches. For this case, we can use like a Raspberry Pis that are on the remote location and servers that are on the HQ locations, or we can use an SD-WAN solution. I think that is also a very interesting use case that we have. Let me think. Anything else interesting? Yeah, we have also developed a use case, but this is a smaller one, but still I think it's a very important one for the network engineers. That is configuration of switches. So if you have like 30 switches and they're on remote, like remote branches, some are on the HQ, some are wherever, we can use these Linux jump servers so that we can connect from automation platform to the actual branches and environments. And first, check what configuration is on the switch and then apply the actual configuration. But sometimes it happens that this configuration is not successfully applied. That's why we have checked the configuration, we have saved it, and then we check after the changes and take that configuration again and use like, this is a functionality of Git. We upload it to Git that is local and check if the actual configuration is done. If it is missing some like configurations and stuff like that, so that we actually know from the configuration that we have pushed to the switches that it is actually there. To summarize, we check initial configuration, do the change, and then check if the configuration was actually applied. Yeah. I hope these give you some ideas or insights to what we can actually do. And it is mostly limited like to the imagination of the one that wants to do the automation. So yeah. Any other questions? We have some time. Okay. So yeah, I want to say thank you for. Oh, Friedrich has a question. Before I continue, you use a. Okay, if I'm getting this right, you use a jump VM to execute the automations. Why do you do that instead of relying on the execution nodes? The jump servers actually are the execution nodes. You use the receptor service that you install on the execution node, which is the Linux jump server. Yeah, yeah. Good question, actually. Yeah, I didn't want to include any extra details to like add complexity to the representation. So yeah, but you're correct. These are execution nodes inside the automation platform. Okay. I guess if you have any further questions, send them to me with anything that you want to follow up upon or have extra discussions. Okay, thanks, Frederick. And I hope that I gave you some insights, some ideas on automation that we can implement in your environment. And yeah, thank you for taking the time for attending this and exploring the power of automation. After this webinar, please please put your insights into the survey that will be opening in the browser. It will actually help me be a better presenter and other insights. So yeah, and of course, if you have any further questions, you can reach out directly to me. I will be happy to have another discussion and share the automation ideas. And of course, either Conscia office or your account manager. I will be very happy to hear from you or anyone else. So yeah, thank you for attending, and yeah, I wish you the best.